So we've defined the unit tangent, the unit normal, and the unit binormal vector. They're three mutually perpendicular vectors that follow the curve and create an axis system at every point. So I wanted to show you what that looked like in this software Mathematica. So I have the vector valued function. I'm going to have it be a helix. So here's my helix, cosine 2 pi t, sine 2 pi t, and t. And in Mathematica, I define the unit tangent vector. It's the derivative of the vector valued function divided by its length. The unit normal vector is the derivative of the unit tangent vector. And the unit binormal vector is the cross product. So I define these functions, and I plotted the curve along with the vectors t. T is the vector in red. That's the vector that's tangent to my curve. The green vector is the unit normal vector. You could see that the unit normal vector is at a 90-degree angle with the unit tangent vector. And the unit binormal vector is in cyan. That is perpendicular to the other two. So I'm going to play this animation, and as the curve gets traced out, as the blue curve gets traced out, the three vectors will move along the curve. So I could see that as the curve's traced out, at every point on the curve, I have this axis system. Let's do another curve. So I have another curve here. I think it's the same curve I showed you in a previous video. So here is an animation of this curve that looks like an infinity sign pushed in a little bit. But we could still have the unit normal, tangent, and binormal vectors move along the curve, creating an axis system. All right, so there is some good computer-generated images of the three vectors, unit tangent in red, unit normal in green, and the unit binormal in teal. Okay.